All right, welcome everybody. We've been talking about logarithms for a couple of days now. We've learned their definition, we've learned how to calculate simple logarithms, we've talked about transformations, and most importantly, we've talked about their relationship to exponentials, which is, of course, that they are inverses. Remember, everything about inverses means opposites. We've had some practice last time doing that with the equations, and now that's going to help us as we go to graph them. We're going to start by graphing these kind of the long way by hand, and then I'm going to show you how to do so with a graphing utility. I'm going to show you how to do so using both the graphing calculator and Desmos, so make sure that you pay close attention to those rules for today. So using a graphing utility, we're going to make a table of values and we're going to graph each of the following. Be sure to find the asymptote, draw it as a dotted line, and then add it to the graph. Remember that no matter what graphing utility you use, it does not actually show you the asymptote, so you have to know that it's there. And of course, an asymptote is a value that the graph is getting closer and closer and closer to, but never actually quite touches. These rules in the middle here about how to put a log into a calculator, we're not going to need those for a couple of minutes, so we'll come back to them, but let me just go ahead and highlight it for when I need it, and so that you know where it's located in the future. But we're going to go ahead and start with the easy one on the left, and the easy one on the left here is the exponential function 3 to the x. So we have made a couple of tables and a couple of graphs of exponentials already, so a couple things we want to review. Generally, when you go to graph an exponential, you like to have a couple of negative values, a couple of positive values, and of course, 0. Something else to notice, so this 3 is larger than 1, so that's how we know this is going to be a growth for exponential. Remember that when it comes to any exponentials, the domain is always all real numbers. Remember that the asymptote only changes from 0 if there's a big plus or minus on the outside. If there isn't anything on the outside, then the asymptote remains at 0. And in this case, it's a horizontal line, so it would be y equals 0. When it comes to the range, we know that the range always has to be the same, or at least have some of the same values as the asymptote, but usually you want to wait until you actually have the graph to do so. So if you had a calculator, you could just do 3 to the negative 2, 3 to the negative 1, but let's go ahead and make sure we could do it using either of our graphing utilities. So let me go ahead and first pull up the graphing calculator. So after you choose your graphing calculator, and if you turn it on, you're going to go ahead and go to the y equals. If there was anything there, you would clear it out. If not, you're going to go ahead and type in your exponential function, which would be 3. Use the caret to create an exponential, and then raise to the x. If there was anything else to type in, you would do so carefully, parentheses, etc. You're going to go ahead and get 3 to the x. Then you're going to go ahead and press the top right, the graph button. It is going to show you what looks like exponential growth. You, of course, have to realize that that's not the whole story because there is an asymptote there, which we'll get back to in a minute. But you also want to be able to find specific values, which instead of calculating them just one at a time, you can have the calculator do for you by making a table. How do you make the table? Well, you're going to press the second key, and then you're going to press the graph button. This is going to bring you up your table of values. So I told you to go from negative 2 to 2, so you will scroll up or down until you get to the appropriate values. We're going to copy those onto our paper in a minute. But again, as you make your x's smaller and smaller and smaller, remember that those y values are also getting smaller and smaller and smaller. Once you start seeing anything with an e to a negative number, that is scientific notation, which means very, very, very small. How small? Well, getting close to 0, why 0? Because that's where the asymptote is. So if I go back here, I'm going to go ahead and start by writing in the y values that I got from the table. So negative 2 was 0.11, negative 1 was 0.33, 1, 3, and 9. Then, of course, you have to remember there is an asymptote at y equals 0. So on the graphing calculator, you can't see it. So you have to add it in. I'm going to go ahead and draw it as a dotted line, as we typically do, because it's not actually a line. It's just a value that we're approaching. Then you're going to go ahead and try your very best to graph these points, keeping in mind that anything that's really, really close to 0, you're essentially just estimating. So you have the 0.01, you have the 0.13, you have the 0.29, and then you're just getting closer and closer and closer to the asymptote. So this is really a pretty good approximation of what's going on. When it comes to the range, compared to the asymptote, it's either going to be above or below. And in this case, it's going to be above, which means 0 to infinity, using a parentheses on the 0 because it's an asymptote, using a parentheses on the infinity always. How would you do that same exercise if you were using the Desmos? So if you were to go ahead and pull up Desmos, if you bring up the graphing calculator, you should be able to type in y equals, and then you can do 3, and then you can use the exponential button here, which would be 3 to the x. You can see that it's going to give you the same picture. You have a slightly different scale. Again, the asymptote is not shown to you, so you have to make sure that you know that it's there. And then let's say you want to see a table of values. If you highlight your function, which in this case is number 1, so highlight means just make sure that it's blue. If you press this little edit button, you're going to have a couple of options here. You're going to choose the first option, which says convert it to a table, and now it's going to give you a table of values. It typically automatically goes from -2 to 2, but you can change those values if you want to by typing in any x, and it will give you back any y. So again, if you need to do this in the future, hopefully now you know where it's located. So let's go ahead and go back to our table here. So now we have the left side done, and now we're going to go ahead and do the right side. So the first thing that I want you to realize is that the left side and the right side, these are inverses. Remember the loop rule. If I took f of x equals 3 to the x, if I followed the 4-step process for finding inverses, I would in fact get log base 3 of x. So if you remember that everything about a log is an inverse, I can take every xy value in this table and I can simply invert them. As I do that, I'm going to rewrite them as a new table, but I'm just going to put it in the right order. So I'm going to do 1, 0, 3, 1. So now that I know that these are inverses, remember everything about inverses means opposite. So I can take any ordered pair from this table on the left and simply invert it to get tables on the right. So if I take all the y values and replace them as x's, I'd get 0.11, 0.33, 139. And then I'm going to go ahead and convert all the x's into y. So -2, -1, 0, 1, and 2. Everything about these functions are opposites, and that includes the domain and the range. So whatever the domain of the original is, that has to be the range of the inverse, which means the range has to be all real numbers. When it comes to the asymptote of the original was y equals 0. Here, it's going to be x equals 0. And whatever the range of the original was now has to be the domain of the inverse. So that is going to give me the values of 0 to infinity. So even before I put that into my calculator, I can see that there has to be an asymptote at x equals 0. So that is going to be a vertical line, which I'm going to draw dashed. Again, it doesn't actually show up on the graph, but I have to know that it's there. So I can kind of estimate what the graph is going to look like using the ordered pairs, but if we want to be sure, let's go ahead and take a look at it on the graphing calculator. So if I go back to the actual graphing calculator and I go back to the y equals, there's a couple of commands you have to do to get the appropriate log. So if we go back to the notes that are written above, it says you have to press the math key, and then you have to scroll until you get the log base option. It's actually easier if you press the up arrow as opposed to the down arrow until you get to the log base option. Once you select that, that now allows you to do log base anything. We're doing log base 3 of x. Now, if you try to do this on your graphing calculator and you do not have a log base option, then that means you're going to need to use Desmos. So I'm going to show you how to do that in a minute, but here we are on the graphing calculator. So again, if you want to see the picture, press the word graph. Again, notice it's not quite showing you the whole picture here, so we have to be careful. And again, if you want to see the table, press second graph. Notice you have a bunch of errors there, and we'll talk about where that is in a minute. The first point you actually have is 1, 0, and then you have a couple of other values. Notice there's a lot of decimals, which tends to be the case for logarithms, which is perfectly fine. I actually already have the values from my table, so all I really wanted to see was the graph here, and now let's kind of put those two things together. So over here, the reason why the graph on the calculator kind of looked cut off was because of the asymptote. The reason why all the negative values said error was because of the domain. You're not allowed to go to the left of 0. So if you go ahead and try to graph what you do have here, you have the point 1, 0, you have the point 3, 1, you have the point 9, 2, and then based on the graph, you could see that it gets smaller and smaller and smaller and closer to the y-axis, but doesn't actually touch it. So it's the same idea of the asymptote getting closer and closer and closer, getting closer and closer and closer, but never actually quite touching it. So again, if you think about it in terms of opposites, the opposite of an exponential shooting up would be a logarithm shooting to the right. And then if you remember in general what the inverse relationship is, we're going to go ahead now and do step 2, which means we're going to put them on the same coordinate plane. When we do that, we are going to start by using a highlighter or a color to draw in the line y equals x. The y equals x line, hopefully you remember, is a diagonal line that goes through the origin with a slope of 1. So it basically goes through the origin and then down 1, left 1, or up 1, right 1 the whole time. So again, this is the line y equals x. That's kind of the magic line whenever we're talking about inverses. And then I'm going to go ahead and take my graphs from above, and I'm going to go ahead and sketch each one. So let's make sure I'm using the right color. So if I start with the red one, again, 0, 1. Actually, I don't want to use red because that's red, so I'll just use green. So 0, 1, 1, 3, 2, 9, and then getting small, small, small. There's my asymptote. And then I'm going to want to go ahead and do the log. So if I go ahead and do the log, I'm going to go ahead and do 1, 0. I'm going to go ahead and do 3, 1. I'm going to do 9, 2. And then I have my vertical asymptote and getting small, 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 and then shooting off to the right. If you look at the green and if you look at the blue, what do you notice about the relationship between the two functions? They are reflections over the line y equals x. And why is that? Because these are inverses. So we kind of already knew that, but now we just want to make sure. So from here, whenever you graph a pair of inverses, they should always be reflections of each other over the line y equals x, which means if I take any point on the green and switch the x and y, that's going to give me the point on the blue. And that also includes the asymptote. So I know I told you I'm going to show you how to put that in the calculator, and I am, but I'm going to save it for the next one. So let's go ahead and take a look at the next pair. Notice again, these are a pair of inverses. I have done them for you, but I'm sure you believe me. The opposite of going up 3 is going right 3, and now we have base 2 for each. Here, we're actually going to start with the logarithm, and then we're going to work backwards and do the exponential. So I need to make a table of values for the logarithm. So I'm going to go ahead and start by doing that on Desmos. So if I go ahead and I go to Desmos, I'm going to go ahead and get rid of that first function. If you want to type a logarithm into Desmos, you have to do y equals. Then you have to press the function button. You have to go over, right arrow, over to the MISC. That means miscellaneous. Notice if you look very closely, you have your ln, which is what you'll need for natural logs. You have your log, which is what you'll need for regular logs. And then you have your log with a little a, and that's the one you're going to want to choose because that allows you to type in anything. So in this particular case, you want to do log base 2. Then you want to make sure that you get into the parentheses. And then you want to do x minus 3. So x minus 3. Notice that here, if you kind of, zoom in a little bit, notice that it looks very similar to the graph that we had in the other problem, with one small but important difference. Instead of the values getting closer and closer to 0, they appear to be getting closer and closer to 3. Why 3? Well, because of the x minus 3, this moved the graph 3 to the right, including the asymptote. Again, if we want a table, we're going to go ahead and press this little edit button. You can then press table, and it will convert it to a table. Now, notice that because of the fact that it automatically goes from -2 to 2, all of those undefineds are because of the fact that those are not allowed in the domain. So the first value that you could even try to pick would be something bigger than 3. So let's say you picked 4. That would give you 0. Then let's say you picked 5. That would give you 1. Let's say you picked 6, 7, 8, 9, 10. Again, I'm just choosing a couple of different values here. You're going to choose enough so that you have about 5 points. You're going to go ahead then and convert them onto your paper. So I'm going to go ahead and take those values and write them on my paper. So I'm on the right-hand side now. Again, a couple of values that I chose. I picked 4, then I picked 5, and I'm going to just choose values that are a little bit spaced apart. You don't have to, but it just gives you a little bit of a nicer picture. So 4 gave me the 0.0, 5 gave me the 0.1, 7 gave me the 0.2, 9, 2.6, and 10, 2.8. And then again, what wasn't obvious, but you have to know that's there, is there's an asymptote. The asymptote in this case is at x equals 3. Why x equals 3? Because of the fact that the graph moved 3 to the right, it also moved the asymptote. Because of that, that means that the domain has to start at 3 and then can only get bigger and bigger. So as I go to plot these values, so 4, 0, 5, 1, 7, 2, and then getting a little bit bigger and bigger. And again, you really don't have to be too precise as long as you have the right general shape, which I think is fair to say looks like this. When it comes to the range, it's going to be an all real number situation always, because it goes all the way up and all the way down. After you realize that, you can take a bunch of that information and just kind of flip-flop it to go ahead and apply to your exponential. So starting with the asymptote, instead of being x equals 3, you're going to have y equals 3. Instead of the domain being 3 to infinity, that's going to be the range. And instead of the range being all real numbers, that's now going to become the domain. So remember, the asymptotes are the same value, but one is x and one is y. The domain and the range should flip-flop, and the domain and the range should flip-flop. Then again, you can take all those values from the table. So 0, 1, 2.6, and 2.8. You can go ahead and simply interchange the x and y. Remember that the asymptote also has to move. So y equals 3 is going to be here. Then you have the 0.04, you have the 0.15, 27. And again, you know that you're approaching the asymptote and then getting larger and larger. So that should make sense. If you, again, think about opposites, the opposite of the log moving right is the exponential moving up. And if you just want to be 100% sure that everything works out perfectly, you can go ahead and put them, again, on the same set of axes here. So start with the line y equals x. Remember, that's the magic inverse line. I'm going to go ahead and start with the log. So remember, the log has a vertical asymptote at 3. I know it goes through the 0.40, 51, and that's really kind of enough for me to get started. Then when it comes to the exponential, I know it has an asymptote of y equals 3. I know it goes through 0.4. I know it goes through 1.5. And then again, as long as it's approaching the asymptote, those two graphs should always be reflections of each other over the line y equals x, which they are in this case. Now that we know exactly what the graphs are supposed to look like, let me show you exactly what the problems that you're expected to do will look like. All right, so for our last couple problems, there was obviously a lot going on today, so I kind of tried to simplify the process here. So you are given a function, you are going to graph it by making a table of values. You're going to tell me the asymptote, the domain, and the range. Then you're going to graph it. Then you're going to find the equation of the inverse, and you're going to graph both of them on the same coordinate plane. So on A, we're going to start with the exponential and then find the logarithmic inverse. And then in B, we're going to do the opposite. So first, let's go ahead and do 2 to the negative x minus 4. Let's use Desmos for that one. So again, if you're a Desmos user, you're going to go ahead and go to the Desmos website. You're going to type in very carefully y equals 2 to the negative x minus 4. You can see here what the graph looks like. Notice it's approaching the asymptote, which even though it's not actually there, you can kind of clearly tell is at negative 4. If you want to go ahead and turn this into a table, you're going to go ahead and press this little edit key. You're going to choose the table option. It always starts with negative 2 to 2, and then you can plug in additional values as needed. So I'm going to take those y values and I'm going to add them onto my worksheet. So if I go back here, I'm going to go ahead and jot down those ordered pairs. So it was negative 2, negative 1, 0, 1, 2, and the y values were 0, negative 2, negative 3, negative 3.5, and negative 3.75. And then again, things that I know for sure, this big old minus 4, that is where the asymptote is. So y equals negative 4. The domain is always, always, always all real numbers. The range, I'm usually going to wait until I draw the picture. If I go ahead and sketch some points, so negative 2 comma 0, negative 1, negative 2, 0, negative 3, and then getting smaller. So I'm going to go ahead and graph it like this. I can see that the range here is above the asymptote, so that's how I know that it's negative 4 to infinity. Then I'm going to go ahead and dot in the line y equals x. That's just going to help me when I go ahead and do the inverse in a minute. So then underneath, you're going to go ahead and find the equation of the inverse using the same process that we've done the whole time. Step 1, you're going to go ahead and change the problem from f of x equals to y equals. So 2 to the negative x minus 4. Then you're going to go ahead and switch the x and the y. So x equals 2 to the negative y minus 4. Now you're going to go ahead and resolve it for y equals. You're eventually going to have to do the loop, but before you can do the loop, you're going to go ahead and add the 4 to the left-hand side. Once you've got it rewritten as such, you're going to go ahead and start with the 2, loop to the other side, and then come back. So start with an log, base 2, x plus 4 equals negative y. And then your final step here, you're going to have to get rid of that negative. So you're going to have to multiply both sides by a negative, which makes the left side negative and the right side positive. So here is your final answer, which again, you can call f inverse. So negative log base 2 of x plus 4. Now, to graph this inverse, you can either take all the values that you have on the original and you can go ahead and just swap them, or you can go back to Desmos and you can go ahead and type this in and it'll show you a little bit of a more precise picture. Let's go ahead and do that just so that we can. And again, if you want to put them on the same coordinate plane, that's fine. So I'm going to go here to equation number 2. I'm going to do y equals negative. If you want there to be a logarithm, remember you have to press function. You have to go to the miscellaneous. You're going to have to choose log base something. So negative log base 2, make sure you go back in the parentheses of x plus 4. And notice here that the graph that's in red, it is moved 4 units to the left. That's because of the asymptote. If you wanted to, you can also type in the line y equals x. Remember, the red graph and the green graph should be reflections of each other. So you can go ahead and take that red graph and add it to your graph here, or you can just take whatever is on the blue and simply, reverse the points to go ahead and create the green. So first of all, I know that there's an asymptote for the log here at negative 4. And then if I go ahead and just invert some of those points, I'm going to get the point 0, negative 2. I'm going to get the point negative 2, negative 1. I'm going to get negative 3, 0. And then as you go ahead and graph that, You can see that the red, not the red, the green and the blue, they are in fact reflections of each other over the line y equals x. It looks a little funny because of the fact that this was 2 to the negative x, and this is a negative log, so they actually have reflections compared to what we've seen so far. But again, as long as it looks right on your Desmos, yours can just kind of be a sketch in terms of how it's supposed to look otherwise. All right, so here in our final example, part B, we're going to go ahead and start with a log, graph it, find the domain, range, and asymptote, and then go ahead and find the equation for the exponential inverse. So I have those points that I already found, but I'm going to go ahead and show you how to do that. Notice I highlighted inside that x plus 5 because of the fact that the asymptote is vertical. It is going to move 5 to the left, which is how I know the asymptote is going to be at x equals negative 5. I know that the range of any log is always all real numbers, and then I'm going to fill in the rest once I go ahead and actually graph my function. So I'm going to use the actual graphing calculator this time. So I'm going to go to that. I would go to the y equals, and I would very carefully type in the equation. Just as a reminder, to bring up the log, you're going to press the math key. Then you're going to scroll up or down to the log base option, and then you can go ahead and plug in whatever values you want. So I already did that for number 1. So remember, if you press the actual graph key, it shows you the picture. It won't always be complete, though, because it doesn't show you the asymptote. So you have to be very careful to put it in yourself. If you actually want to see values in the table, you're going to press second graph, and that's going to bring you up the table. Notice that negative 5 or lower are all errors. That's because of both the asymptote and the domain restrictions. So you're going to grab any 5 ordered pairs from here. You don't always have to go from negative 2 to 2. In fact, I didn't in this case. I just chose a couple of nice looking values. So the ones that I picked are as follows. So you can go ahead and jot those down. Then you're going to go ahead and actually graph them. So I'm going to go ahead and graph each of these ordered pairs. So negative 4, negative 2, negative 3, negative 1.5, negative 1, negative 1, 0, negative 8, 1, negative 5. So I can see that this log is going to travel along the asymptote, and then it's going to be rising very, 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 very slowly. I could find out exactly where it crosses the x-axis if I wanted to, but estimation is perfectly fine in this case. Again, the asymptote is maybe the most important part. It's not going to show up ever on any of your graphing utilities. So you have to make sure you add that in for yourself. And then I'm going to go ahead and put in the line y equals x. That's going to help me when I do my inverse. Then based on the picture, the domain, because it's to the right of negative 5, I'm going to go ahead and say negative 5, to infinity. So now from here, I'm going to go ahead and find the equation for the inverse. So underneath, I'm going to take the g of x equals, and I'm going to change it to a y equals. So y equals log base 4 of x plus 5 minus 2. Then I'm going to go ahead and switch the x and y. So x equals log base 4 of y plus 5 minus 2. Before I can do any looping, I'm going to have to add the 2 to the left side. Remember, you can never do the loop if anyone is going to be left out. And only once I'm here can I go ahead and do 4 raised to the x plus 2 equals y plus 5, which means my final answer would be to have 4 to the x plus 2 minus 5 equals, and you can change that back to the inverse notation. Remember, you can plug this into your graphing calculator as well, and you can actually see the graph pop up, or you can just take everything that you know here about this function, you can take the original and just kind of invert everything. So if you want to do it that way, you're going to go ahead and start by drawing an asymptote at y equals negative 5. And then you're going to take each of those values from the table and simply invert them. So negative 2, negative 4, negative 1, negative 1. Notice that would stay the same, which should make sense because it's on the line. Then you would have negative 1.5, negative 3. And again, you could kind of, estimate as many as you want, but you know that this graph is going to look like such. It will eventually cross the y-axis. Again, we could find that point exactly if we wanted to, but as long as your two graphs are mirror images of each other over the line y equals x, that's kind of the whole point. So that concludes our lesson for today. Thanks very much for tuning in, guys, and we will catch you next time.